The first derivative is a powerful tool that can tell us a lot about a graph. When we find the critical values by setting the derivative equal to 0, we can find out where we might have a possibility, minimum and maximum. If the graph changes from decreasing to increasing or increasing to decreasing, then we have an extrema. If the graph doesn't change, if it's increasing and increasing, well, that's not an extrema. If it's decreasing on the left and decreasing on the right, then it's not an extrema. And the way we find out if it's increasing or decreasing is we find out if the value of f prime is changing from negative to positive. Remember, a negative derivative, first derivative value, is decreasing. A positive first derivative value is increasing. So let's try this out in a couple functions here to find out if they're increasing and decreasing, and we'll use that to help us figure out if we got minimums or maximums. All right, so here we have a function, a cubic function. We want to find the first derivative, so f prime of x, 3x squared minus 6x, and this should be getting pretty quick. Here we have it. Now, we want to factor this if it's possible, and a lot of times these are made to factor. It looks like 3 can be factored out. That's one way to go. X squared plus 2x and minus 8, right? So that can be factored into x plus 4 and x minus 2. So some quick factoring. There's our derivative. Now, we want to find the critical values, and then we'll check in between them. So let's start with the critical values here. We want to set that equal to 0. 3 times x plus 4 times x minus 2 equals 0. So that happens, we can tell when x equals negative 4 or x equals 2. So there's our critical values right there. Doesn't mean they're minimums and maximums, but we know they're critical values. All right, so what we're going to do is we're going to make a number line here. This number line is very powerful, very useful. And this we're going to label as f prime. So on our f prime number line, at negative 4 and 2, we know that we have some critical values. So what we're going to do is we're going to check to see what happens to the derivative in between each of these. Well, this one's easy in between because 0 falls in between here. So we're going to pick a number in between, and the derivative is going to be the same in between here. Okay, it's going to be either all positive or all negative, and that's thanks to the intermediate value theorem that tells us that since the derivative is continuous here, if we know it's 0 here and 0 here, and there's no 0 in between, then it can't change signs. Well, so what we're going to do is we're going to try, let's try 0. Okay, so 0 is in between here. So we're going to plug 0 into this function here. Now you can use the derivative in any form, but probably your best derivative or your easiest derivative to work with is going to be the factored form. Because once we plug in 0 there, we can see that we've got 3 times a positive number, and this is going to be 0 minus 2, that's going to be a negative number. So 0 times 3 times a positive times a negative, positive, positive, negative, that's going to be a negative number. So down here on the number line, we'll put a negative. All right, what if we pick a number to the right of 2? Pick something like 3 over here. Plug in 3 to each of these. What do we get? Well, we get 3 plus 4. That is a positive number. All right. So if we plug in 3, we get a positive. Plug in 3 here, we get a positive. So everything's positive, so that's going to be positive. What if we plug in negative 5? Something to the left of negative 4. Probably don't want to plug in decimal numbers. Well, if we plug in negative 5 there, then we end up with negative 5 plus 4 is negative. Negative 5 minus 2 is negative. So we have a negative times a negative times 3. And that's going to be a positive. So we've tested in between each value there. And so we found out that for this section here, the graph is going to be increasing. Here the graph is going to be decreasing. Here the graph is going to be increasing. And since this is going up and down here, this is going to be a max. Since the function is going to be going down and up, this is going to be a minimum. So the question for this problem was determine the increasing and decreasing intervals. So we went over and above with the min and the max, but that's all right. Increasing here, we've got from negative infinity to negative 4, soft brackets. Okay, that's this section here. From this section here, it's going to start at 2 and going to infinity. Remember, we're just talking x values here. So 2 to infinity. Now decreasing is in between, and that's going to be negative 4 to 2. All right. So, all right, let's try another one. What about this guy here? So let's take our derivative. We need our chain rule. So f prime of x, derivative of the inside is 2x, times the derivative of the whole, leaving the inside alone. So that's going to be 2/3 times the inside. Subtract 1 from 2/3, we get 1/3. And you're going to want to clean this up a little bit. We want to have positive exponents. So this is going to go downstairs. We can put it down with a 3. We have 2x times 2 on top. So this is 4x all over 3 times x squared minus 4 to the 1/3. Okay. There's our derivative. Now we want to set this equal to 0. So where is f prime of x equal to 0? So that's going to happen when the numerator is 0. Well, what makes the numerator 0? 4x equal to 0, and that's when x is equal to 0. We also got to watch out what makes the denominator 0, because that's going to make the whole thing undefined. And when the derivative is undefined, that is a critical value. So what makes 3 times x squared minus 4 to the 1/3 equals 0? Well, that's when that parentheses equals 0. So divide by 3 here, and then cube it. Okay, so we want x squared minus 4 equals 0. Add 4, square root, x equal plus or minus 2. Right, so actually 3 answers there. So now, let's find our intervals of increasing and decreasing by looking at these intervals. We have 0, 2, and negative 2. So let's test some points. And let's see. Let's test starting on the right. How about 3? So when we plug 3 in here, we get positive on top, and plug in 3 here. It's going to be 9 minus 4, which is positive. This whole thing's positive. So positive over positive, which is positive. All right? So this guy's going to be positive. How about we plug in 1, something in between here. So if we plug in 1, the top will be positive. Plug in 1, the bottom is going to be negative, because 1 squared minus 4 is going to be negative. So positive over negative is going to be a negative number. Plug in negative 1. Well, we're going to get negative on top. We're going to get negative 1 squared is 1 minus 4 is negative. So we're going to get negative on the bottom. And so that's going to be a positive. And then last but not least, let's try something to the left of negative 2, like negative 3. Plug in negative 3, you're going to get negative on top. And then negative 3 down here is going to give you 9 minus 4. That's going to be positive. So this whole thing's going to be negative. Okay? So that's what it's going to look like there. Okay? Now, we also have some points here of discontinuity, and that's at x equals -2 and x equals +2. Now, the question here was just what is the increasing and decreasing? Okay, so increasing is going to be from -2 to 0. Everywhere this is positive, and from 2 to infinity. Decreasing is going to be from -infinity to -2, and from 0 to 2. So that's what we're looking for there. Now, if we want to go a step further here, we can see this, that we have, this is decreasing, this is increasing, decreasing, increasing. That's going to make this a minimum. That's going to make this a max, and this a minimum. Okay? We don't exactly know what the rest of the shape will look like. We just kind of know where the min and max will be. Okay? All right, so we got derivatives of increasing, decreasing here. Okay, we've got a rational function. So we're going to have to remember our quotient rule here. Derivative of the top, 4x cubed times the bottom, minus the top times the derivative of the bottom, which will be 2x. And that's all over x to the 4th. Now, how do we deal with something like this? We don't want to multiply that whole thing out. What we want to do is we want to factor out a common factor. And I think we're looking at, we've got an x and we've got a 2. Okay, so we can factor some of that. So 2x. And what's left behind? Well, with this first term, which is really 4x to the 5th, we'll have 2x to the 4th. Minus, and we've got x to the 4th. Be real careful with your parentheses here. All over x to the 4th. Okay. And let's clean up the inside a little bit here. That might help. So we have 2x to the 4th minus x to the 4th. That's going to be 1x to the 4th minus 1 all over x to the 4th. Don't go trying to divide these two. Okay. We could cancel one of these out here, I suppose. And we could make this x cubed over and 2 on the top. That'll work. All right. So there it is, simplified. Simplified doesn't mean multiply it all out. It means just fewer factors. All right. So we want to set that equal to 0. So let's do that. F prime of x. We set equal to 0. Well, that's going to be 0 when the top is 0. So 2 times x squared minus 1 equals 0. Divide by 2. Add 1. Square root. And you get plus or minus the square root of 1. Okay, so there's our critical values. Square root of 1, which is 1, of course. All right, so plus or minus 1 there. We don't need the square roots here. Let's get rid of that square root. All right, so plus or minus 1. And then also our critical values is going to be at x equals 0. There's another one because of that denominator. That makes the derivative undefined. All right, so now let's go ahead and do our number line. We've got 0, 1, and -1, right? And now we've got to find, at those functions, we've got to find f prime of x. So we're going to evaluate f prime at those values, all right? So at 1, at values above and below that. So plug in this, maybe let's go 2, okay? So plug in 2 to f prime. And so f prime of x, when x is 2, we're going to get positive on top, because that's 2 to the 4th, which is 16, minus 1. and positive on the bottom. So we get positive over positive, which is positive. Then let's plug in maybe a half. A half is a number in between here. So plug in a half, it's positive on the bottom. A half to the fourth power is going to be 1 over 16. Minus 1 is going to be a negative. So we're going to have negative on top and positive on bottom, and that's going to be negative. Then let's go for negative a half. So negative a half, plug it in here, it's going to be negative on the bottom. Top is going to be negative again, so we're going to have negative over negative, which is positive. And then something over on the left side, how about a negative 2? Plug that in, you're going to get negative on the bottom. It's going to be positive because of the fourth power. On top, minus 1, it's all going to come out positive. So positive on top, negative on bottom. So that's going to be positive over negative, which is negative. Okay? So that tells us that we are increasing. Let's go ahead and fill the number line in here. We have positive over here, negative, positive, negative. So we're going down, going up, down, up. And that gives us a minimum here. That gives us a max. And this one's going to be a minimum. All right, so we have our increasing functions or increasing intervals, and that's going to be from -1 to 0, and from 1 to infinity. We've got decreasing, and that is from negative infinity to -1, and from 0 to 1. There we have it. All right, we kind of jumped the gun on this last one. Can we tell if it's more than increasing, decreasing? We can. It also tells us the mins and maxes, and that is the first derivative test there. All right? So that's how you use the first derivative to find out the critical values there and use the increasing and decreasing of the function to tell what kind of critical values they are.